For the seventh exercise of the data mining lab, I am going to perform the ensemble based classification. Here I am going to do three tasks in under the topic on ensemble based classification. Ensemble based more for the first section, that is for ensemble of same model applied on the subset of fields. I have retrieved the gold as dataset for the experiment, and I have connected to the random forest data model. The random forest operator generates a set of specified number of random trees. The resulting model is a voting model of all the trees. So from this random forest, I have given the output to the apply model. I have applied this model, and to this apply model I have also given a test case from the retrieve golf test set, which is already available in the rapid miner, and from that I have given the lab and model as the output. Now let's check what's happening here. So this is the example set which I have given. This is the golf data set which was given. So this is the random forest model which is being generated. This is one tree where the wind is the root node. Where wind is false, the outlook will be overcast is equal to yes, rain will be yes, sunny will be no. So, and if wind is true means outlook will be overcast will be yes, rain will be. Total 10 trees are generated. Outlook for the outlook root node, one tree is generated. For wind out root node, one tree is generated. For temperature root node, for temperature greater than 84, less than 84, this tree is generated. So this is one ensemble based classification which is based on the same model and applied on the subset. For the ensemble based classification on the same data which is boosting, we are going to use with AdaBoost. For this for classification, so we have retrieved the data from the data sonar. This is the we have retrieved the data sonar, and we have used split validation for the functions to run inside that. So inside this validation, for in the training phase, we have given AdaBoost as the model. Inside the AdaBoost, we need to give one model, that is a decision tree. So this decision tree will go output as the model, and we will apply this model and do the performance based on classification, and the performance will go as the average. And from this validation, the model and from this validation, this model and average will go as the result. Now let's see what's going to happen. In this performance vector, the accuracy is 66.13%. The accuracy is being checked here. And in this AdaBoost, one model is being checked. The attribute 11 is being generated. We will check what is attribute 11. So this is the attribute 11. Based on this attribute 11, the first model's root is being formed, and the subtree, the decision tree subtree is also being formed, and the rock mine also are being classified based on the attribute subtree nodes. Model 2 is also being checked. Here attribute 45 is the root node, where the values above 0.385 is classified as 1, and less than or equal to 0.385 in attribute 45 is classified as another one. Another one is based on attribute 49 as root. This is for this tree attribute 36 as the root, and attribute 23 and 10 as the subtrees. Like this 10 models have been made. So this adabus is also I have done. So now we will do the ensemble of the same model applied on the subsets of records, that is with bagging. So for this bagging also we have retrieved the Sona dataset, and from Sona dataset we have given the output to the validation. The validation used is split validation. Inside this validation for the training phase we have given the model as bagging. Inside the bagging we should give the model as decision tree and give the output for the model code. And in the testing phase we will place the apply model and the sample test, and from that performance based on classification is also given, and the average is given as the output. From the validation the model and the average is also given as the output. Now let's execute this and find the output. So now the performance output is also we have got. The accuracy is 62.90 and the true rock true mine class precision is also we have got. In the bagging we have got the decision trees as the output. We have got 10 decision trees in the bagging. Here in the first decision tree is attribute 11, which is the first output. For model 2 it's also attribute 11. So in this bagging we can find that for inferring all the models we have received, all the models are showing the same type of decision tree. Means all the models are having attribute 11 as the root node and the attribute 39 and attribute 1 as the subtrees for that, and for rest follows. For all the it is also given. Here it's attribute 52 and attribute 1. So it's been for all the values here the attribute 11 is the root node for the model. So I have performed three classifications, three ensemble based classifications using the bagging, adabus and random forest. Thank you for watching this video.